Now, welcome to another episode. I'm Ishola David, blessing my name, popularly known as General David. Now, this episode will be looking at operation on set. Now, operation on set. Now, what are the operations on the set? The first one we'll be looking at is union of set. Now, what's a union of the set? If sets A and B are subsets, or let me even say, yes, if sets A and set B are subset of a particular universal set, then the union of the set is defined as elements that are found in A or B or in both without the replacement. Now, what are we talking about? When we are talking about the union of the sets, now see this one. If you have this structure like this, let's talk about the Venn diagram. If you have this set A and you have this set B, if you have 1, you have 2, 3, 4, you have 5 here. Now the A union B, this is a symbol of the union of the set. This is a symbol. If you have A union B is now the combination of the words of the A and B. That is, we have 1, we have 2, 3, 4, and we have 5. Now, let's get to this. Another example is this. If set A is equals to 4, 2, let's say 4, 2, 3, 1, and 6. And you have set B to be equals to 1, 5, 7, 3, 8, 5. 8, let's say 6. Now, you know, say what is A union B? A union B is we have to combine these two without repetition. Let's first start with the first one. First one is 4, 2, 3, 1, 6. Then let us come to the second one. The second one is now you have 1 year. Is 1 year already? Yes. So you don't need to write it. Then 5. Is 5 year? No. You include it. 7 is here. Is 7 year already? No. You include it. 3 is here. Is 3 year? Yes. You don't need to write it again. 8 is here. Is 8 year? No. You have to include it. 6 is there, 6 here, yes, so you don't need to include it. So this is the answer. Can you see that the A union B is the combination of these two sets without the repetition of the words of the numbers. So now you have to get to another one. Now the second one is intersection of the words of the set. Now what's the intersection of the set? Now intersection of the set, the symbol is this. Now what is it? Now, the intersection means the elements that are common in both sets. Now, what are we talking about? Let's firstly talk about the Venn diagram first. And I'm still using the previous structure. If you have B here, you have A here. You have 1, you have 2, you have 3, you have 4, you have 5. So now, this place, this is the site for the union of the set. This is the site for the union of the set. But we are talking about the intersection of the set. Intersection is just this where they are what? Where they are in common. So what they have in common, don't forget that what is here is 3. So what is here is 3. So that means the N intersection B of this one is equal to what? 3. The intersection of the what? Of the two sets here is equal to what? Is equal to 3. And that means if you have A to be equal to, let's use this example. That's 4, 2, 3, 1, 6. And B is equal to, you have 1, 5, 7, 3, 8, 6. Now what is now A intersection B? A intersection B means what they have in common. Now let us start. 4 is here, is 4 here, no. 2 is here, is 2 here, no. 3 is here, is 3 here, yes. So that's one part of the intersection. 1 is here, is 1 here, yes. You write it. 6 is here, 6 here, yes, you write it. So what they have in common is what is known as intersection. But union of the two sets is combination. So that's why I have to start with A. I wrote all the A, then you now start with B. Like 1 is here, you've already written 1. 5 is here, you've not written it, you write it. 7 is here, you've not written it, you write it. 3 is here, 3 is here already, so you don't write it. 8 is here, so 8 is not here already, so you write it. So that's how you write intersection. But this intersection and this one is what? Is union. So next one we talk about. Let's move to the third one. And if you are talking about the third one, we talk about the disjoint set. Disjoint. Now, what is disjoint set? Disjoint sets are sets that does not have anything in common. That is, A intersection B. That is, they don't have anything in common. So their intersection is equal to what? 0. They don't have anything in common. A intersection B is equal to 0. Now, if you want to draw the structure of disjoint set, they don't have anything in common. So their circle will be what? Will be different. So they don't have anything in common. So we are talking about disjoint set. So imagine you have set A to be 4, 5, 6. So imagine this one, and B is equal to, let's say you have 1, 2, 3. Now, what is A intersection B? What do they have in common? 4 is here, is 4 here, no. 5 is here, is 5 here, no. 6 is here, is 6 here, no. So they don't have anything in common. So the intersection is 0, is empty, or use this empty set like this. So that is what we know as disjoint set. Now the next one is complement of a set. Complement of a set. Now the complement of a set is like this. If you are using A now, A complement like this, or you have it like this, this is a complement of a set. Now complement of a set is the universal set minus the set. Now what do you mean by that? If you are saying A complement now, we can say A prime. That's equal to universal set minus that A. This is the formula for the complement of a set. Now, what are we talking about? Imagine that you have universal set to be all alphabet. Universal set is all alphabet. You have set A to be English consonants. English consonants. Now, they now ask you that, what is A complement? A complement, now if you want to find A complement solution, A complement will be, you are going to remove all the A from universal set. Now, everybody, you believe with me that if you remove all the consonants, all English consonants from all alphabet, definitely it will remain all what? All English vowels. So it will remain what? It will remain vowels. So that is A complement. Now another one is that if you have universal set to be, let's say 4, 2, 6, 7, 8, and you have A to be equal to 2, 6, 2, 7. Let's say you have B to be 4, 8. Then they now ask you that, what is A complement? A complement here means, let us remove all the elements of A from universal set. That means we have 2 here, we have 2 here. We have 7 here, we have 7 here. So what are now the remaining values in A, in universal set? After we've removed A from universal set, you know, this is 2, this is 2, this is 7, this is 7. So what are the remaining values in universal set? That's 4, 6, and 8. So this is the example of what? Of A complement. So that's A complement. Now for the B complement now, B complement will be like, oh yeah, this is 4, this is 4, this is 8, this is 8. So the remaining values will just be 2, 6, 7. So when you remove that set from the universal set, the remaining values give us the complement of the words of the set. Now the next one, number 5 now. Number 5, we talk about difference of two sets. Now what is the difference of two sets? Now we are saying difference of two sets. Now imagine you have set A to be 5, 6, 7, 8, 2, and you have set B to be 2, 1, 3, and 7. Let's see now. Now everybody, you have to know that A minus B, they say what's A minus B is different from B minus A. Now you have to understand the fact that if you want to calculate 4 minus 3, you have to, if I want to use another method that is 1, 2, 3, 4, and I have 1, 2, 3. Now 4 minus 3 would be, I will remove all these one cancel 1, another one cancel 1, another one cancel 1. So 4 minus 3 will now be the value that remain in what? In 4. That's 1. So therefore, if you are saying A minus B, you remove all the element of B from A. So the remaining value in A is your answer for A minus B. for b minus a, you remove all the element of a from b. The remaining value in b is your answer. Now let us see. A minus b. Our a is 5, 6, 7, 8, 2. Minus our b is 2, 1, 3, 7. So let us now remove. What is the remaining values? Now you can see that what they have in common, 7 is here, 7 is here. 3 is here, is 3 here, no. 1 is here, 1 is here, no. 2 is here, 2 is here. So the answer will now be what remains in A. And what remains in A is 5, 6, 8. Now what is B minus A? What's our B? 2, 1, 3, 7. Minus, what's our B? Our A rather. A is 5, 6, 7, 8, 2. Now what they have in common? So 2 is here, is 2 here, yes. You cancel. 1 is here, is 1 here, no. 3 is here, is 3 here, no. 7 is here, 7 here, yes. So what remains in B is now your answer, which means you have 1, 3. So that is B minus A, and which is different from A minus B. Now next one, number 6. We talk about the symmetric difference. Symmetric difference of two sets. Now symmetric difference of two sets has formula. If you say A symmetric B, this is the symbol. A symmetric B, it has a formula which is A minus B, then union B minus A. A minus B union B minus A. That's a symmetric difference. Now if you have if you have A to be equal to 4, 5, 6, and you have B to be equal to 7, 5, 2. Let us now see. So that means if you now ask to find A symmetric B is A minus B union then B minus A. You know that. Now let us find what is A minus B. A minus B is equal to, now what's our A? 4, 5, 6 minus what's our B? 7, 5, 2. Don't forget that A minus B will now be what remaining what in A is our answer. That means 4 is here, is 4 here, no. 5 is here, is 5 here, yes. 6 here, is 6 here, no. So what remaining in A is your answer, which is 4, 6. Now what is B minus A? B minus A, you have B to be 7, 5, 2. Then minus your A, which is 4, 5, 6. Now let us cancel. 7 is here, 7 here, no. 5 is here, is 5 here, yes. 2 is here, is 2 here, no. So B minus A will now be what remaining in B. And what remaining in B is 7, 2. Now we now say A symmetric B is now the combination of what? Of A minus B and B minus A without repetition. Oh yeah, let us now combine the two. We now have the first one is 4, 6 and second one is 7, 2. So this is the answer to A symmetric B. So whenever you are asked to find the symmetric of two sets, this is how you do it. Now, another aspect we talk about. We talk about the laws of set. The laws of set. Now, what is the laws of set? The first one is the Morgan's law. Now, what is the Morgan's law? The Morgan's law made us to understand that the first one, I'll be talking about two cases. The first one will have it to be A union B complement to be equal to A complement intersection B complement. And the second case is A intersection B complement is equal to A complement union B complement. Now let me expatiate this. Now for the first one is A union B or complement. Now let us use the complement to open this bracket. How do we arrive from here to this place? Open this bracket. You are going to use this complement to open this bracket. That means you have A complement, then union complement, B complement. That's it. That's when you use the complement here to open this bracket here. This is what you are going to have. But take note that union complement is equal to intersection, and intersection complement is equal to union. So since we have it, this will now become A complement. What's union complement? Union complement here is intersection. So that's why we have intersection, then what? Then B complement. That is how we got this. And at the same time, the second one, which is A intersection B or complement, will now be, if you use the complement to open the bracket, that's A complement, intersection complement, B complement. Then don't forget this becomes A complement. What's intersection complement? Intersection complement is union. Then we have what? We have B complement. That is how we derive the what? We derive this value. Number two law, we have what's known as associative law. Now, what is associative law? Associative law made us to understand that if you have something like A union B, then union C, because associative law, the second case of associative law will be A intersection B intersection C. Can you see that they have the same thing? Associative law is from the word association, so they have the same sign throughout. Then we now have this. So what you are saying is that this can also become A union into brackets B union C, and this one can also be A intersection B intersection C. Now, what associative law is talking about is that you observe that they have the same set sign, union union, intersection intersection. So what is telling you is that any set can come first. Now, as you can see that C is outside there, A is outside there, so they are the same because they have the same word, they have the same set law and the same set sign. So that is in associative law. Even I can have it to become B union into brackets A union C is the same thing. Even this place I can have it to be B intersection A intersection C. So that is what? That is associative law. Now the third one is distributive law. Now distributive law is opposite of associative law. Now what are we talking about? Now if you have something like A union B intersection C, if you check this one, or you have A intersection B union C. Now if you check this one, is different from associative law because this one has opposite set sign. This one as well, can you see that is opposite set sign? Now if you are talking about this distributive law now, let's talk about this distributive law. For this one now, this one will now become A union B intersection A union C, and this one will become A intersection B then union A intersection C. Now how do we arrive to this point? Now let me prove it here. Now if you are talking about distributive law here, now let me use this process so that you can understand better. Now what's the process I want to use is that if you want to expatiate 4 multiplied by 2 plus 3, now on a reasonable sense I can say that 2 plus 3, that's 6, 6 times 4, that's equals to what? 24. But you know that this 24 I may not pass through 2 plus 3, sorry, let's do it again. 2 plus 3, that's 5 rather. 2 plus 3 is 5, so 5 times 4, that's 20. Now I may not be able to pass through that process. I can use the process of, let me use this 4 to open this bracket. This thing can become 4 here. I will now use the sign outside here to multiply this. That will now be 4 multiplied by 2. Then what's the sign in between them? That's plus. Plus 4 multiplied by what? Multiplied by the second one, which is 3. And we say 4 times 2, that's what? 8. Plus 4 times 3, that's 12. What's the answer? 20. Can you see that they are the same thing? It gave us 20 that way. But I want to use this process I use there to open this distributive law. That means I have this with this sign outside to multiply the first one. Then the sign in between will be the one in between here. So then there's number here as well to multiply the other one. That's why we have this A here union this multiplied by the first one, which is what? B. So A union B, then the sign in between, which is intersection, then A union the second one, which is C. Then the second one here is A intersection, the first one, which is what? B, then the sign in between, which is union, then A intersection, the next one, which is what? C. That's distributive law. Then the third one, we have it to be commutative law. Commutative law. Now what is commutative law? Commutative law says that if you have A union B, it's the same thing as B union A, or you have A intersection B, it's the same thing as B intersection A. So what commutative law is trying to induce is that you can just change it anyhow. Like once it is just 2 like this, A can come first before what? Before B. So that is the difference between all this law. Now this is where we are going to stop for today. Now at the comment section, I want you to give me the answer to this one. Number 1 is that, what if you have A union empty set? What's the answer? And number 2, what if you have A let me give you another one. A intersection universal set. What's the answer? A union empty set. What's the answer? Then A intersection universal set. What's the answer? At the comment section, let me have the answer to this. Thank you very much. I remain Inshallah the blessing, popularly known as General David. Like, comment, and subscribe. share for other people to use. God bless you. Thank you very much.